You will have to forgive me, please. I know in the agenda it says we have a 10-minute break, but I do want to, we've got only one more session to go, which is the rules processing session led by Michael Richards and James Bush. So if you can hang in tight there for another 30 or so minutes, we can pass through this session and then get done with the day. So I will queue up Michael and James. Are you guys ready to go?
I'm ready.
Yes, go for it.
Okay, you're seeing my, oh, you're not seeing my video yet? You're seeing my, oh, you're seeing my video. Fantastic. So here I find myself in the unenviable position of standing between you and the end of the day. But one of the great things about a virtual convening is that you can't see people getting up and walking out. They just do it quietly without anybody even noticing. I also just wanted to comment that I imagine I'm not alone in appreciating the irony of the fact that we're running late because of the performance session. Anyway, this is a naked plea for sympathy. I want to talk about the work that we've been doing in a couple of different areas relating to rules processing. And in particular, the fact that because it's proved a possibility in several different areas, which I'll talk about in a moment, we would like to devote some energy in the next PI to sorting out a Mojaloop-wide way of doing this, basically because we need to do it for particular instances, but it would be better, I think, if we could do it in a way that was extensible and which enabled other people to use it for their particular purposes. So what problem do we need to solve? We have some specific requirements. TIPS, for instance, in Tanzania needed to calculate and record interchange fees, but only for some types of transfer. And they will to extend that as well to other types of transfer in the future. And as those of you who had the joy of attending the settlement presentation on Tuesday will already know, Mojaloop would like to categorize transfers according to their own rules. And we think that's quite a general need, in fact. So what's the general version of the problem? Essentially, we need to be able to evaluate a specific rule for every transfer, that's for every transaction that's being processed in the switch, and then take some action as a consequence of evaluating that. Now, obviously, this will need to be efficient, hopefully generic, and we would also like it, if at all possible, to be capable of being controlled by administrators rather than software developers. I mean, it's in the nature of these rules, we think, and particularly, for instance, of the sorts of example that I'll be talking about in TIPS, that people will change them. And when they do change them, they won't want to have to go back to the development team in order to implement those changes if they, for instance, just want to change the rate, that kind of thing. One of the things that a career in software development and related activities has taught me is that essentially people think something is expensive if they think it's difficult. So changing a rate typically is something that people don't think is very difficult, and they're therefore less than happy if you tell them it's going to take 3 months. Anyway, moving right along. So what do we want? First of all, we want a way of executing a rule-based evaluation of an interchange fee to start with. Second, we want a framework which will enable us to execute a variable number of such evaluations, i.e. we don't want to be able to say, well, you can have a rule, but you can only have 1 or 5 or 3 or however many. We need to be able to change them while the switch is running. And also we need to be able to locate them at different points, we think, in the end-to-end transfer process. Third, we need a way of representing an evaluation in human-readable text form, and by human I mean non-developer. We need a deterministic way of turning that into a way of actually executing a rule. Then we probably need a user interface to allow administrators to create and modify these evaluations, preferably with sorts of safeguards that prevent them bringing the system to its knees. And then we need a deterministic way of turning that into something that goes through the interface, i.e. number 3. So what are the critical success factors? Well, they're different for the different stages. As far as evaluating the rule goes, efficiency of operation is the #1 criteria. This is something which typically might happen while a transfer is being processed, and therefore anything that causes unnecessary drag on that process is going to show up eventually on performance and throughput. The framework needs to be also efficient in operation, and also needs to be stateless. I mean, we want something where we can just load individual rules without needing to worry about what other rules might be present in the system. For the interface, it needs to be clear and concise. And for the user interface, it needs to be easy to use and responsive to changes in data structures and requirements, new functionalities, new facilities. We should have ways of making sure that administrators can take advantage of those as they become available. So I'm really going to start at the bottom end of this, which is the way we decided to start with tips. We needed a way of executing a rule-based evaluation and the framework to handle those. So we just stick to ourselves in the first instance of these requirements on the basis that if we did them efficiently, we would A, be able to meet our specific requirements for implementing in Tanzania, and B, have something that we could give us a defined target when we came to look at further up the stack. So let me look then at the specific tip solution. Requirement was as follows. If the transaction was a wallet-to-wallet, P2P, person-to-person transaction, then the receiver pays the sender 0.6% of the value of the transfer. Also, there were no interchange fees for on-us transactions. Interchange fees were to be recorded by the switch, and the net obligations consequent on these were going to be aggregated by the switch and communicated to participants on a regular cycle. But participants weren't required to maintain liquidity cover for interchange fee obligations. Essentially, it was seen as a matter for settling between the various mobile money systems and something which didn't need liquidity cover. So the assumptions we made were, first of all, that all the information that was required would be contained in the transaction object, however that was defined. So that's something that goes around. So it's initially constructed by the payee DFSP as part of the quote response, but it contains essentially the terms under which the transfer is maintained. We expected then that we would hold the account type for the payer and payee in the extension list of the transaction object. They would have these key names and the values could be set either to wallet or account. And that structure would enable us to define whether a particular transaction was indeed a wallet-to-wallet transaction, and therefore it needed to have something done as a consequence. So we said, what's the most efficient way of evaluating a rule? And our answer was direct code. So something like the following. Now, the reason I was proposing on this presentation to act as the glamorous assistant to Professor Bush is, you can see this has real code in it, and therefore I'm not qualified to pronounce on these matters. So any technical questions, Professor Bush will be taking them up when he joins, and I'm sure he will take pleasure in answering them for you. So if you do have questions, you may ask them of me. I will probably say, no idea, Governor. And if you can then put them in the discourse page, then I'm sure Professor Bush will get back to you with an answer that will more than satisfy you. So the first part of this rule then excludes on-us transactions, i.e. the payer FSP ID has got to be not equal to the payer FSP. Second, we only want wallet-to-wallet transfers. And that says when we get the extension value whose name is account type for the payee and the payer, they are both equal to wallet. We now take a brief excursion into the jungle that is transaction type definition in Mojaloop, and you will have to take it from me that whatever it looks like, that means this is a P2P payment. Okay? Trust me on this one, it's true. Then we take some action if all of these things are true. First of all, we log that we're adding an interchange fee. And then we call a method, which is a generic function, to add a ledger, I'll rephrase that, to add a ledger entry. So that says what kind of ledger entry it is, or what kind of account type it is, what kind of ledger entry type it is, how much it's going to be, and this, please don't beat me up on arithmetic, Miller, but that's what it is at the moment. That's the currency, and we have the payer and the payee as the two parties to the ledger. So that'll create two matching ledger entries, one for the payer and one for the payee of that amount. Well, obviously the sign will be reversed for one of them. Okay, so that's how it works. It's a relatively simple piece of JavaScript. And therefore we would kind of hope relatively efficient, or at least it's hard to see how we could get it more efficient apart from writing in a proper programming language. Oops. Okay, so the next question is, how do we load these things into the system? And now I'm afraid we are really going to come into areas where I am tiptoeing with trepidation. So I hope you'll give me an easy time. So here's a brief description of the structure that we're using. So first of all, we have our own handler, which is the transfer settlement handler. That listens to an existing Kafka stream. And when it picks something up, it executes a script which is contained in a virtual machine. New and changed rules, and this is the point about having them in a virtual machine, are loaded by adding them to the Helm chart that defines the VM. And that means that if we get a new script file, a new rule that is, all we need to do is add it to the Helm chart and it will automatically get reloaded. Kudos to Neil Donnan, who is the guy who begot this idea. And then finally, the action that's taken updates the central ledger database. So that's how that works. So where have we got to? We've got a structure for defining the rule, which essentially enables us to define when the rule should fire and what to do when it does fire, which is log it and do a matching pair of ledger entries. We also have a general way of executing and updating rules. They listen to Kafka streams. They can be attached, in principle at least, to multiple handlers. They run in virtual machines. They're loaded by Helm chart definitions for those virtual machines. And the functions available will depend, obviously, on the handler in which it's executed. So where do we want to go from here? First of all, we think we'll probably need to add some execution locations, or at least know how we're going to do that in the future. And we will also need to add new rule actions. In particular, if we're going to support the categorization of settlements, we will need to have something that adds a categorization and allows the rule definition to say what kind of categorization it should be. Further down the line, we would look at representing rules to administrators and defining a rules API to convert administrator rules into actually executing rules. So finally, this is the playing about bit now. What might a user interface look like? Well, if we had a simple Excel-based one, you might start with some enumerations to map the underlying JSON types onto simpler text types. So if you just pick something called payer identifier, then it translates into that representation of where it is in the transaction object. You might compose that into rules with comprehensible names. Might say something like that. So transaction is not an on-us transfer, equates to the payee DFSP is not equal to the payer DFSP. And essentially that gives us the structure that we looked at in the JavaScript further back. Then we can make the whole thing into an interchange fee test. And we can say the if the transaction is not an on-us transfer and the transaction is a wallet-to-wallet transfer and the transaction is a P2P transaction, then we do that. And that is automatically translated into something which, as you can see, has a great number of brackets, but does actually represent a version of what was done there. So that is just a quick hack. You could do it much better, of course. But to get going, all you need to have is a syntax of how to construct a rule definition and a process to execute it. And I see that it's not even 5 o'clock, and I've got to the end. So it only remains for me to throw myself on your mercy and say, please vote for the rules processor when it comes to the actual division of votes tomorrow. Any questions?
You're not supposed to ask that directly, Michael, but all right.
I have no shame. That's the problem.
There are some questions in the Q&A chat. I see.
Oh, okay.
James is on the call, so I don't know if you want to.
Oh, cool. Excellent. Sorry, let me see if I can check out the Q&A chat. Yes, probably, Dorota, is my answer. I would expect that what we would, so this is a question really about how we would do that in the case of adding categories for Mojaloop. And my answer is I expect that the category would be added as part of the quote preparation. It would be put into the extension list of the transaction object by the payee DFSP, and it would come through to the rules processing in that way. Neil's question, sorry, does that answer your question? Okay, apparently it does. Neil's question, how do rules fire? Yes, the scripts are run in memory and they are executed by the handler. So what happens is the handler is constantly getting messages off the Kafka queue, stream, sorry, I meant to say, and asking, does this rule apply to this message? So it's listening. Updated rules get introduced by updating the Helm definition for the virtual machine in which the rules run. So that provides us with a neat way. Again, I want to credit Neil Donnan for inventing this. Provides us with a neat way of saying, when we've got new rules, all we have to do is update the Helm chart for that VM, and they will automatically get loaded into the process. So that's how.
And Michael, is there a process of ordering them so that you end up with rule 1, then rule 2, then rule 3, and the ability for a rule to say, and stop looking at other rules? So you have both an order and a chain that's formed for these?
Not at present. At present, we are adhering furiously to the declarative pattern. But that's not to say that we couldn't include such a thing.
It is actually declarative. It's used in mail processors. The declarative thing that is added to it, which feels not so declarative, but it is the order in which the rules are looked at. So in other words, yep. I look at rule 1 before I look at rule 2, and there's a way for a rule to say, I'm the end of the chain. I stop looking at other rules. If I actually do something with this thing, then no one else does anything with it from this point.
Yes. Now, it would certainly be possible to introduce such a thing, At the moment, we are thinking of these rules as probably being orthogonal to each other. And that if you wanted to chain things together in that way, then that would be something that you could do in a single rule. But that's not to say that we couldn't extend the syntax to include the use case that you talk about, Miller.
Yeah, actually what I'm saying is what you're saying, but in a different way, which is they are orthogonal. That is, they each get a taste of the raw message as it comes in, but that there's a specific order in which they look at them, so that a decision made early and that takes an action on that message, the environment has been modified when the next rule then gets a look at the message. The message itself has not necessarily been modified. So it doesn't have to be that the messages are being modified by the rules, but the environment may be acted upon by a rule.
Absolutely.
One of the actions that the rule could take is stop looking at more rules. It's just it's an arbitrary short-circuiting of that. But it does then allow you to create these sort of independent rules that are all stacked together with an understanding that order might matter.
Sure. And an obvious use case for that is something where you evaluate a rule and it says, cancel this transaction, it's an error.
I think we have all the questions answered.
But we've got 5 minutes to go.
We do.
James, you'll have to sing a song.
Please, no, anything but that.
Thanks so much, Michael and James.
Okay, thank you.
With those 5 minutes, I want to pass that over to Kim. That brings us to the end of the day. But just before I let you all go, tomorrow is it's probably my favorite and the most important day in this convening, where we get to give all of you a chance to vote on the roadmap items. So I'll pass it off to Kim to give a rundown of how that's going to work.
And especially on rules.
Great. Thank you very much, Simeon. And again, we've heard so many exciting topics this week. And the fun part is for you guys to vote on what you guys want to discuss. And more importantly, what are we going to work on for the next PI, the programming increment. If you go to mojaloop.io/vote, you will see all the topics that we discussed in chronological order. I encourage you guys to look through these topics as well tonight, or this morning and tomorrow morning, or what have you. So, and then once you're ready, tomorrow after we go through these topics clearly, we'll go ahead and vote on this. You can actually vote now if you're ready. Each person will have 3 votes. And the way this looks like is you go into Power Noodle. We did this last time. You can go to Workstream Topics. These Workstream Topics correlate to that mojaloop.io/vote page. If you're concerned about the discussion or what happened, you can look here, and that gives you the description of that. To vote, you can just go ahead and select the slider. So you have 3 votes. You can use all your votes on one, or you can allocate those across. You can change your votes at any time up to our midday point tomorrow. So there you go. That's kind of the voting, and we'll go through this instruction again, but this is, again, you can go ahead and vote and change your vote up to that point in the agenda where we stop voting. And then once we come back from the break, we'll go ahead and we'll have different work stream breakout sessions where you can actually join and influence the work of that particular session.
Awesome. Thank you so much, Kim. I posted the links in the chat there for you for easy, just to make it clickable for most people. So we're definitely looking forward to seeing you all tomorrow. Paula, do you have any last comments before we close today?
Well, I just want to say nice job, Simeon, in keeping us on track all week. You've had to catch up a few times, but thanks for being the tough guy and keeping everyone on track. Appreciate it.
I appreciate that. So I will give you all 2.5 minutes back of your time. Enjoy the rest of your day. See you tomorrow, everyone.
Thank you, guys. Bye.
Thanks, everyone.